All right, this is by request, a question 5 from page 325. It is on stoichiometry. It does not have anything to do with limiting reagent just yet. So I would expect that everyone should be able to follow along with just bare minimum backgrounds on just basic understanding of moles. So the question is on the decomposition of calcium hydroxide into calcium oxide and water. And lucky for us, the equation itself is already balanced. The coefficient is a 1, and a 1. The question says, if I have 1 gram, 1.00 grams of calcium hydroxide, how many grams of calcium oxide is going to be produced? How much can we expect? Right away, I recognize that this is going to be a question of stoichiometry. So even if I don't need this chart, I'm actually going to draw out the chart that I almost always do for stoichiometry. Oops, sorry. Always do for stoichiometry. And on the left side, I am going to have mass, molar mass, and the number of moles, which of course comes from our equation there. If you don't know what that is, or if you're not quite familiar, you definitely need to review, okay? Big time. Once again, the question is, how many grams, so if I have 1.00 grams of calcium hydroxide, how many grams of calcium oxide do I have? And you might be tempted to go from 1.00 grams all the way and just directly go to calcium oxide, but you actually can't do that. I lied. You could. It takes a lot of work and doesn't work all the time for more complex situations. What you really, really want to do at this point in time is try to get into the groove of calculating the number of moles for every single situation. Okay? That is the only way you can go from one section of this equation to another section of this equation. If you calculate the number of moles of calcium hydroxide, you can then use mole ratios to calculate how many moles of calcium oxide you have. And then with that number, we're going to go back and get the number that we've wanted from the very beginning. This 1, 2, 3 step calculation is what you are going to try to accomplish for this question. So let's get to it, shall we? I'm going to use a different color. So your goal right now, step 1, is to calculate the number of moles of calcium hydroxide. This equation is going to come in handy. Here we go. The mass of CaOH2 is going to be 1.00 grams. Great. The molar mass, CaOH2, is going to be, let's see, 1 calcium with 2 oxygens with 2 hydrogens. That's going to be 0 plus 32 plus 0.2, 74.1 grams per mole. So I'm going to put that in there, 74.1 grams per mole. And N is equal to mass over molar mass, which is 1.00 grams over 74.1 grams, which gives you 0.013495276, which is basically approximately 0.0135 moles. I'm going to use a different color and plug that in. This belongs right here. Good job. Step 2. Now that we have the number of moles of calcium hydroxide, how many moles of calcium oxide do I have? Well, let's organize. The number of moles can only be calculated using mole ratio. Once again, we had said it before. The number of moles is fixed under mole ratio. based on the coefficient of the chemical reaction. 1 mole, 1 mole. The mole ratio is 1 to 1. I'm going to write this down. Number of moles of calcium hydroxide to the number of moles of calcium oxide is going to be 1 to 1. Well, that's great, but what if I start with 0.0135 moles? How many moles of calcium oxide do I have? Number of moles of calcium hydroxide, number of moles of calcium oxide. Cross multiply, X is going to equal 0.0135. Okay. Now I know you could probably use common sense to do that, but if the mole ratios are more complex and the numbers are not very nice, you're gonna need to know how to do the cross multiplying. You need to know how to do the mole ratio. So get some practice. 0.0325 belongs right here. You're done step 2. Let's do the very last arrow. The number of moles of calcium oxide. Just to be true to this, let's use a different color to show this is a new step in the thing. So we have number of moles of calcium oxide is 0.0135. What is the molar mass of calcium oxide? It is calcium and oxygen, give me 56.08 grams per mole. So mass is going to be that top equation modified, or rearranged rather, which is 0.0135 multiplied by 56.08, which is 0.75708, which is approximately 0.5757 moles. Grams. Sorry about that. Okay, that's it. So to answer the question, if I have 1.00 grams of calcium hydroxide, I should expect 0.757 grams of calcium oxide. And that's it. Orally, I'm going to quickly go through questions B, C, D, and E because it's a good refresher to some of the reasons why we can do stoichiometry. Let's do this. Part B, predict the mass of water expected. Well, if I started with 1 gram and I get 0.757, by law of conservation of mass, I should have 1 minus 0.757, which is 0.243 grams of water. It only makes sense. Part C, is stoichiometry required to solve B? No. As I said just now, I needed conservation of mass, the law of conservation of mass. Part D, what law of chemical reactions do your answers to A and B illustrate? Law of definite proportions, I suppose. I am not quite sure what the main goal of that question was, but it does make sense. Part E, a student incorrectly predicted that 1 gram of calcium hydroxide produces 1 gram of calcium oxide and 1 gram of water. Why is this prediction incorrect? I could go back to what I said before about law of conservation of mass. If I start with 1 gram, there's no way I can create 2 grams worth of products. Unless you're some magician or you just created matter of nothing and you have some powers of God or something like that, right? That's a little bit awkward, a little bit scary. And assuming that you don't know how to create matter out of thin air, well, 1.00 should give you a total of 1.00. Hope that helps. That is once again number 5 from page 325 on stoichiometry. Thanks for asking the question and hope to hear from you soon. Bye.